this third presentation in our series of webinars covering plant-based beverage processing. I'd like to thank you for joining today. Today we will be focusing on the mixing opportunities, and it's my goal to cover all mixing opportunities within plant-based beverages for different capacities, different CAPEX, OPEX, sustainable solutions, and keeping the quality of the final product in mind. In many examples, I have used oat as the reference plant. For mixing, the similarities to all the other plant-based products are very, very identical. First, a little about myself. I'm Ulla Skytte, and I'm the Global Technology Sales Manager for the mixing portfolio within SPX Flow, Nutrition and Health. I joined SPX APV in 2006, so I have been here 17 years. Before that, I worked with Arla Food Ingredients, Danisco Food Ingredients, and Aarhus Karlshamn. I have a master's degree in food science from the Royal Veterinary and Agricultural University in Copenhagen. During my career, I have been member in many committees. I have been in the European Whey Producers Association in Brussels, also in the Calorie Control Councils in the US, and I have been in Leatherhead Food RA, both as a committee member and as a co-chairman to Steve Beckett from Nestle from 2002 to 2006. I have given many presentations and written many articles, and I have also been the author of 2 chapters in 2 different books published by Wiley in the UK. Our purpose is to improve the world through innovative and sustainable solutions. The agenda for my presentation today is that I'll first go through the general oat beverage processing plant with focus on where the mixers can do benefits from you. I will cover the challenges, and I will especially focusing on 3 different options for mixing opportunities in plant-based processing. First, the liquiverter, which is for the flour or the raw material handling or dispersion. Then our Flex Mix Instant, the vacuum mixer for the final formulation. And finally, I will cover our inline cavitator, which can give you great OPEX and CAPEX saving possibilities. Last, I will mention all the upcoming webinars that will come in the near future. And finally, we'll do the questioning and answering. Today, you're not able to answer any questions during my presentation. So if you have a question, please put it in the chat and I will address it in the end of this seminar. And if I don't have time to do all of them, I'll get back to you personally afterwards on email. Here you see a general process of a plant-based beverage processing. This is again with the example of oat. Normally you will start with the flour, but if you start with the grain or the raw materials, flakes, then you will need a grinding prior the startup of the mixing process. If we start with flour, the aim is that you dump the flour into hot water and add enzymes so you get a lower viscosity in your mass, which you can use for the beverage final process. You will create an oat base. If you do big capacities, you will have benefits by using the liquiverter. And if you have smaller capacities, then you can use our Venturi-based TPM mixer. After the hydrolysis, after the enzymes have been doing their work, you then have a heating, inactivation process and cooling. and you are taking off the undissolvable parts before you go to the final formulation, which is we recommend to use our FlexMix vacuum mixer because it gives you the best quality. And then downstream the process, you will have the final heating and homogenization and filling. So the challenges in plant-based beverage processing is, first of all, to have the right quality of your final product. The taste, the color, the emulsification, and the appearance, all over appearance of the product. Then, of course, the raw material and the processing equipment that you are using and the cost of those. And finally, the surroundings, the regulations, the allergens, first of all, sustainability, and to keeping and working on getting a green world, automation flexibilities, and so on. The mixing possibilities in plant-based processing, the first one I have here in the left is the FlexMix liqueverter. This can create high capacity processing prior enzyme treatment. So you can add quite a lot of the flour in a very short time of period. It works that you have a square form tank and you're dumping down the powder, and then you in the bottom have a high shear mixer, which will get it dispersed, mixed if it's mixable, and then you're actually just taking it out of the tank straight away. This mixer can also be used to make the final formulation, but to do the final formulation, we recommend to use our FlexMix Instant, the vacuum mixer, where you're getting all the powders in by a vacuum. You can have an automatic deaeration during the processing, and also you can separate the wet and the dry phases totally, so it's much more hygienic mixing. And on the right side, you see the cavitator. It's an inline mixer, which can give you great OPEX and CAPEX solutions possibilities, which I will cover in the end of my presentation. First, the liqueverter. Here you see that you can add all the flours. You can actually just dump it down into the liqueverter via a sophisticated or very simple powder handling equipment. When it comes to the liqueverter, it will just get dispersed into the hot water, and it will then be passing through very, very quickly out of the liqueverter again. So you're not so much focusing on the mixing purposes. What you're focusing on is to get the powder into liquid in big amount. You can actually add up to 25 cubic meters per hour. That means you can actually make 50,000 liters if you're doing a 1-to-1. So a very high capacity and a very high flow. This you can see here in a kind of PNID. You can connect the liqueverter with a big bag station or dumping station, get it down, and then you are putting in the enzyme here, and then you go to the hydrolysis tank, and after some certain time, you will go further to the separator or decanter, and then next to the final formulation in your process. I am then covering the final formulation. And as I said before, we recommend to use our FlexMix vacuum mixer. Here you can see an example where we have two mixers. You have a fat melting unit, and in the right side, you have the powder handling. Between the production and the powder handling, you have a wall. That means you can separate your dry area where you're doing all your weighing of the dry ingredients, and you have the wet area where you have all your liquids and the wet processing. Then you just have a pipeline through from the powder handling into the mixer, and you will then keep it in closed systems. So this is absolutely the highest hygienic processing setup you can have. Since it's vacuum mixers, then you will get rid of the air that you're sucking in together with the powder. Very, very quickly, it will be drawn off with the vacuum pump, and thereby you are creating a good denaturated product to send further into your process. You can do very high capacities. We have examples of more than 100,000 liter tanks that is mixed with a mixer of only 2,000 liter. And finally, it's the most secure solution for the future, because very often when you have started out making plant-based beverages, you also want to enhance your product portfolio with more products like fermented product, like desserts, whipping product, ice cream, or sauces and dressings and so on. And here with the vacuum mixer, you can do all of them. This here is a setup example also where you're using the instant mixer where you have big bag addition. Here it is an example of where you're using total recombination of ingredients to create your final formulation. That means you're buying all your product in powdered form. So you have your protein isolates, oat or whatever plant you're making, your sugars, then you will have your minors, which is the stabilizers, the vitamins and the minerals, and then you will add the fat and the emulsifier into the process. So you are having no starting up process with working with grains, flakes, or flours. You buy all your ingredients. You can also use the same setup. You will just use less powder with using the plant-based and then prepare that before, or you can buy the plant-based from a sub-supplier. I don't expect you to be able to read this one, but this is just to sum up that when you're making plant-based beverages, you can do it in 3 different steps. If you take all 3 steps, you start with the grains and flakes, and then you need to blanch them, to grind them, and to formulate them. And then you need the flours for the enzyme treatment before you come to the final formulation with the vacuum mixer. This is, of course, a very long step. It's also the most expensive from a CapEx point of view, but you have more control of your raw material. You can define the taste and the performance of your raw material in this process. And the raw material you're buying is also the most cheapest one. So the cost of raw material will be the lowest. If you then jump on in step 2, that means you're buying the flour, which has already been processed. And then you just do the enzyme treatment to get the starch molecules to become smaller molecules and thereby having a lower viscosity for the final formulation. This is the next cheapest solution, so the next less CapEx, and you have more control over the base you're making, how long time and which enzymes you're using. And then finally, you can buy all the ingredients, as I said, the proteins, the carbs, and all the other functional ingredients, and just do the mixing and continue to the thermal treatment. This is definitely the cheapest solution from a CapEx point of view, but you have less control of the final product, the taste, and it's also the most expensive one from an ingredients point of view. But it's quite common that if you are a small producer, that you can start up, build up a market using the purchased ingredients. And then when you have a good platform for your product, you will typically enhance to first the flour and possibly all the way down to the grain and flakes formulation. Now I'll turn into the cavitator, which is an inline instant hydration equipment. It is actually a rotor with a lot of holes that is spinning in a liquid chamber, as you can see here down below. It's entering from the central inlet and just one pass coming out on the other side of the cavitator. So just this one spinning, the product will get down in the holes. There it will start to cavitate, and it is cavitation as you know it from valves and pumps. The difference is that we are controlling the cavitation, and we control it by a back pressure valve. For just this one single pass, you actually achieve instant hydration of your ingredients. If your ingredients is macromolecules and dissolvable in water. The cavitator helps all the water molecules to find all the hydrophilic groups on the big macromolecules and then instant hydrate them. Here on the top, you can see an example of pectin where we have just been added 3% into water. It is tap water, 15 degrees, where high methoxypectin is not dissolvable. We did not do any premix, so we have a lot of fish eyes and lumps. And then we just send it one pass to the cavitator using 60 Hertz, and everything was just totally dissolved. No grains, no lumps, no fish eyes. This means that you can do instant hydration of your ingredients. In all these formulations here, you have stabilizers. So whether you're using pectin, carrageenan, which you see on the left side here, the blue one, also instant hydration, xanthan gum, gellan gum, guar gum, locust bean gum, all these one step through the cavitator and 100% hydrated. This can help you save money because very often food producers are adding more stabilizers than needed because they know they are losing product into the filters or using product during the process. So if you are seeing blocking in your filters, you should consider using a cavitator or trying a cavitator to see if we can help you reduce these losses. And every time you can save loss, you have gained cost saving. It's very easy to build in, and it will reduce the amount of hydration tank as well, which you can see here. This is an example with protein. This is dairy protein, milk protein isolate, and whey protein isolate in a blend. I expect the same to happen if it's plant-based protein. I just don't have the same pictures because both of these proteins are dissolvable macromolecules. Here you can see with the green curve that just one pass through the cavitator, you get fully hydration of just one pass through the cavitator. You achieve the same effect or impact as if you are having your product 1 hour in a hydration tank. This means that you can actually speed up your capacity if your downstream equipment can handle a higher capacity, or you can reduce in the amount of tanks, agitators, pump, general GPE in your processing line because you don't need all the hydration tanks because you can immediately after passing through the cavitator go to the next step in your process. This is just an appetizer for you. What can the cavitator help you with in both OPEX and CAPEX savings? Here on the right side, I just calculated that if you can save 0.07% stabilizer in your recipe because you will have no waste in your filters or during your process, then if you are making 12,000 liters per hour, producing 16 hours per day, and having a yearly capacity of 250 days per year, it adds up to be more than $500,000 for just 0.07. The cavitator itself will cost around $55. This is for 14 inch. that can handle between 14 to 20,000 liters per hour. You will need some feed pump, flow meters, and instruments. I have set that to 20,000, so the investment for installing a cavitator will be in the area of 75,000. Then for each tank you can remove, you will be saving 50, maybe more. I don't know the cost of your tanks. So you can very quickly get down to status quo or even a capex saving. On OPEX, the cavitator will give you also a heat impact. If you're running 12,000 liters per hour, then it will be in the area of 3 degrees. This you can save in the next step in your heating process. And it's also often green energy. You will also be able to have a better homogenization impact from your homogenizer. You might be able to save in the pressure used. You will definitely have a much lesser maintenance cost because the cavitator will feed the homogenizer with a very uniform, smooth product, so the homogenizer will be running smoothly in the process. I'd be very happy to help to look into your process, see if we can assist you saving money, either if it's OPEX or CAPEX. I will be able to and help you with these calculations, and we can come up to see if we together can save some money. So we are only promoting the cavitator if we can create a win-win situation. Now I come to the end. This was the third presentation. The next one would be homogenization. It will be in the end of January, and you will have an invitation prior the next event. Look out for all these presentations, which will happen in the beginning and spring of 2024. So every day is Earth Day. And now I would like to open up for the questioning and answering. So let me see the questions that have come in. The first question, we have a shear pump for inline hydration and emulsification after pre-mixing. Would the cavitator be a better solution? And yes, that's a very good question. And we actually have some experience within comparing and benchmarking the shear pump against the cavitator. Our experience is that with the shear pump, you typically have to pass up to 5 times, where in the cavitator, only 1. And if the shear pump and the cavitator is running with the same speed, for instance, 50 Hertz, then yes, the cavitator uses twice amount of energy, but you achieve 4 times better in the hydration and particle size reduction. As far as I remember, the shear pump was about 16 micron for the emulsification, and the cavitator was around 4 micron. And on top of that, the cavitator actually also give you the heat. All the energy that you are adding in will turn into heat, which is beneficial in this process, where we couldn't record any temperature increase using the shear pump. I hope that was answering your question. Let me see what more we have. Yeah, that's about the energy. I heard you said that the cavitator was green and sustainable energy. I thought it used a lot of kilowatts. And yes, it is correct that the cavitator use a lot of energy, but it's green energy. it's electrical energy that can come from green sources. I would say it's about comparing an electrical car, which is running on green energy, compared to a car running on gasoline. So for the heating and for the process using the cavitator, you can reduce your carbon footprint and make a better sustainable world. Where if you're using any sources where you're using still carbon energy sources, you will still be influencing the carbon footprint. Yeah. Let me see if there's any other questions. Yeah, you said that you could use the liquiverter for the final formulation, but you haven't really informed anything about the benefits using the liquiverter. Yeah, this is correct. You can use the liquiverter for the final formulation, and the benefits compared to the vacuum mixer, which I was talking most about, is definitely the price. It's less in price, and it requires less skill for the operators to run the liquiverter, where the vacuum mixer is a much more automated system. But compared to the vacuum mixer, you will not get rid of the air. You will have, you cannot separate the dry and the wet phases in the same way as with the vacuum mixer. And the mixing efficiency, the share rates are lower than with the vacuum mixer. But yes, you can use it. And then you have your homogenizer to do the most part of the emulsification process. I think that is. Let me go down here. Ah, this one. Can the cavitator be used to replace the homogenizer? Also a very good question. As I said, with the cavitator, and now if you're running, let's say, 6,000 liters per hour using our 12-inch, you're running 60 hertz, then you can get particle sizes down to 2 micron. So if you want to have particle size, the fat globule size is comparable to milk, and they will not separate and go to the top, then you will need a homogenizer. But it will create a very homogeneous, nice, distributed product that you feed into your homogenizer. And the homogenizer will run much more smoothly, and you will have much less maintenance cost than if you were not having a good premix, whether you're using the cavitator or the vacuum mixer. Let me see if there's more questions. I think. Yeah, I can also look at the timing. So, but if you have any further questions, please feel free to contact me. You will have my email from the recorded session here, and I'll be very happy to assist you in any way regarding to the mixing. Next presentation, as I said, would be in January, and that would be the homogenizers. I don't know the date yet, but you will be hearing about it in advance time. So I hope you'll join the next seminar as well. And I would like to thank you for joining today. And I hope you have been listening to some wise information about the mixing process. Thank you very much.